Hello, chemistry students. I'm Taylor, here with my partner Serena, and we're here to tell you about thermodynamics. Q equals mc delta T. First, let's talk about heat capacity. The heat capacity of a system is the quantity of heat required to change its temperature by 1 degree Celsius. This is different than the specific heat capacity of a substance, which can be used to quantify the relationship between the amount of heat added to a given amount of the substance and the corresponding temperature increase. In other words, the amount of heat required to raise the temperature of 1 gram of substance 1 degree Celsius. The equation Q equals mc delta T, where Q is the amount of heat in joules, m is the mass of the substance in grams, C is the specific heat capacity in joules divided by grams degrees Celsius, and delta T is the temperature change in degrees Celsius, or Kelvin. The following example utilizes this equation. Suppose you find a copper penny in the snow. How much heat is absorbed by the penny as it warms from the temperature of the snow, which is -8 degrees Celsius, to the temperature of your body, 37 degrees Celsius? Assume the penny is pure copper and has a mass of 3.10 grams. In this problem, we are given the mass, 3.10 grams, and the temperature change, delta T, 37 degrees Celsius minus -8 degrees Celsius equals 45 degrees Celsius, using final minus initial temperature. Each substance has its own heat capacity. In this case, the heat capacity of copper is 0.385 joules divided by grams degrees Celsius. These numbers will be given to you on your test. Using these known values, we can plug them into the Q equals mc delta T equation in order to find Q, which is heat. Q equals 3.10 grams times 0.385 joules divided by grams times degrees Celsius times 45 degrees Celsius. You cancel out the matching units and plug it into the calculator to get an answer of 53.7 joules. To check your work, we can see that the sign of Q should be positive because the penny absorbed heat from the surroundings. Now let's look at another problem in which Q is negative. Calculate the heat change associated with cooling a 350 gram aluminum bar from 70 degrees Celsius to 25 degrees Celsius. In this problem, we are given the mass, 350 grams, and the temperature change, delta T, 25 degrees Celsius minus 70 degrees Celsius, which is -45 degrees Celsius. The specific heat capacity of aluminum in this case is 0.902 joules divided by grams degrees Celsius. Using these values, we can plug them into Q equals mc delta T in order to find Q, heat. Q equals 350 grams times 0.905 joules divided by grams times degrees Celsius times -45 degrees Celsius. Cancel out the matching units and plug it into the calculator to get an answer of -14,253.75 joules. When we look at the numbers in the problem, we see that there should be 3 significant figures, so the number is actually -14,200 joules. We know that this answer is right because the sign of Q should be negative because the aluminum is releasing heat to the surroundings. With enough practice, you'll become a master at solving heat capacity problems. Thanks for watching. Like and subscribe down below.